Hello, let's dive a little bit deeper into two-way frequency tables. So let's talk about joint relative frequency, marginal relative frequency, and conditional relative frequency. So joint relative frequencies are the values in each category divided by the total number of values shown in the shaded cells in the table. Each value is divided, so for example over here, the total amount of 7 plus 3 is 10, 8 plus 2 is 10, so the total amount is 20. So the joint relative frequencies would be to divide each of these numbers by 20. So a two-way table is useful to organize data that can be categorized by two variables. Suppose that you ask 20 children and adult whether they like broccoli. The table shows one way to arrange the data. So this is the children and the adult, yes and no. Well, 3 children say they like it, 8 say they do not. 7 adults say they like it, and 2 say they do not. To find the joint relative frequencies, I will divide each of these values by 20. And here is my solution. So here is my joint. Oops. Rectangle is going a little too big. This is my joint. So I think it was 3. Go back. Yep, 3 divided by 20. If you put that in your calculator, 3 divided by 20, you should get 0.15. And so on and so forth. Now the marginal relative frequencies are found by adding the joint relative frequencies in each row and column. So for example, 0.15 and 0.4 total to be 0.55. So this is considered marginal. The totals. So everything in the total is considered the marginal relative frequencies. 0.15 plus 0.35 equals 0.5. Conditional relative frequencies is to divide the joint relative frequencies by the marginal relative frequencies. And conditional relative frequencies can be used to find conditional probabilities. So for our course, when we find conditional probabilities, we will use the conditional relative frequencies by using our two-way frequency tables. All right, so here is an example. It says find the joint and marginal relative frequencies. It says the table shows the results of randomly selected car insurance quotes for 125 cars made by an insurance company in 1 week. Make a table of joint and marginal relative frequencies. All right, so here's my table. There's a total of 125. So I've come over here and I've copied it again. The only thing that I'm missing is the total. And then the total here for my marginal. And so everything will be divided by 125. So 15 divided by 125. 4 divided by 125. Add them. Oh, no, sorry. 9 divided by 125. Now I add them. Then 53 divided by 125 is 0.42. 4. 32 divided by 125 is 0.256. And then 12 divided by 125 is 0.096. And I add those values up. And I get 0.776. So I'm adding them up. Going this way now, I need to add them going this way. So that's 0.12 plus 0.424 gives me 0.544, and I have 0.032 plus 0.5256 is 0.288, and then 0.072 plus 0.096 gives me 0.168. Then I have to add the totals here and here. And the way that I check myself is that they should equal up to 1. So I'm going to add 0.44 plus 0.288 plus 0.168. I do get 1. Check going this way. 0.224 plus 0.776 is 1. Okay? So we know we did it right. Alright, it says divide each value by 125, and that's what we did to find the joint relative frequencies, and then add each row and column to find the marginal. And so this is exactly what ours look like. Well, not exactly. My handwriting is not that great, but hopefully you get the picture. Alright, so it says, let's do it again. The table shows the number of books sold at a library sale. Make a table of joint and marginal relative frequencies. So, hardcover, paperback, fiction and nonfiction. These are the books that were sold. So, you can pause the video if you like and try to do it by yourself. I have it here. The only thing I'm missing is my total column. Okay, so hopefully the first thing you did was find out the total amount of books sold, period. So that would be 28 plus 94 plus 52 plus plus 36 equals 210. And so this is the value that I'm going to divide each number by. So that's going to be 28 divided by 210. 0.133 repeating. 94 divided by 210, which is 0.4. We'll round to 8. 52 divided by 210. 0.248. Now this time our values might be a little bit off. Remember, we wanted them to total up to 1 at the very last one because we're rounding. But we should get very, very close to 1. 36 divided by 210. 0.171. So then I'm going to add them. So that's 0.13 plus 2.248 gives me 0.381. 0.448 plus 0.171 gives me 0.619. Then going this way, so 0.133 plus 0.448 gives me 0.581. 0.248 plus 0.171 gives me 0.419. Then we add those. So 0.581 plus 0.419 is 1. And then 0.381 plus 0.619 gives me 1. So I did that correctly. Alright, so we did this, and this is what our table looked like when we did it. Alright, next one, it says a reporter asked 150 voters if they plan to vote in favor of a new library and a new arena. The table shows the results. So here, the people who voted for the arena, and here are the people that voted for the library. Alright, so again, the only thing that I'm missing is the total. they told me the total amount of people, it was 150 voters. So each value will be divided by 150. Please feel free to pause the video and do it yourself first. I'm going to go ahead and get started. So 21 divided by 150 is 0.14. 57 divided by 150 is 0.38. 30 divided by 150 is 0.2. And 42 divided by 150 is 0.28. So here are my joint. Let's find the marginal. So I'm going to add them. So 0.14 plus 0.2 gives me 0.34. 0.38 plus 0.28 gives me 0.66. And 0.14 plus 0.38 gives me 0.52. And 0.2 plus 0.28 gives me 0.48. Then I want to find the total, so I'm going to add this together, and it gives me 1. And I add this together, it gives me 1, so I know that I did it correctly. Next it says, so here we have it. It says, if you are given that a voter plans to vote no to the new library, what is the probability the voter also plans to say no to the new arena? So this is the conditional probability that we were talking about. And so conditional probability, if you remember from the formula that we were given earlier, is the joint relative frequency divided by the marginal. And it's also, when we talk about conditional, the given part is always at the bottom. So it says you are given that voters plan to vote no on the new library. So since we are given that, we know that that is the marginal. So let's find it here. Voters plan to vote no on the new library. All right, so new library, they plan to vote no. So that is, people that are planning to vote no are 0.48. And that's my marginal, so that's going to go here. Then it says, what is the probability that the voters also plans to say no to the new arena? So then we're going to go to the joint and find the new arena where they're saying no to it at. The people that are saying no to the new arena is 0.28. So the new arena, no, and no is 0.28. So that's going up here. And I'm going to divide that. And I get 0.58. So this is our decimal. If we want to say percent, 58% says. So it would be 58% chance. So that's what they have here also. So it would be a 58% chance that they'll say no to the new arena. All right, let's not do that one. Oh man, they already gave us the answer for that one also. I want to do another conditional with you. Okay, so let's try this one. It says a company sells items in a store online through a catalog. A manager recorded whether or not 50 sales made one day were paid for by a gift card. Use conditional probability to determine which method a customer is most likely to pay with the gift card. All right, so here are our values. We're going to divide each value by 50. So 6 divided by 50, 9 divided by 50, 5 divided by 50, and so on and so forth. I'm not going to do it this time. I'm going to go ahead and pull it up for us. And so here is what we would get when we divide those things. Everything totals to 1. It tells us the answer already. I don't know why it does that. But we can go ahead and calculate to see. So remember, it is the joint relative frequency divided by the marginal relative frequency. And because I'm running out of time, it's my marginal, which is 0.3, divided by my joint, which is 0.12. That's 0.4. 0.41, 0.38, so they are right. You're more likely to pay